going to be recorded. So just for the record, I'm going to start explaining about the research methods that we have already done, but now we are going to do it once again, and it's going to be recorded on the CNET, so everyone can watch it or rewatch it. We have the research methods here. Tell me if you can hear it, if you can see it, sorry.
Yeah, I can see it.
Okay, very good. So the class of research methods is going to be in 3 parts. This is the first. I'm going to try to do the second and the third, not in a virtual class, but just me, myself recording and then upload it. I will try, I don't know yet.
Okay.
So the first part, we're going to cover variables, hypotheses, sampling, and qualitative and quantitative research. We have done it, so it's just to take a look again, okay? And what is the process of research? We have a small diagram right here, where we can see in which way we're going to conduct our research in the future. Okay, design a base layout, then we're going to create the variations and define our test plan, collect data, run with the best option, and then to get our results, and then try to rerun the test or with small difference. So let's go with the variables. We have independent variables, which, as you know, are the ones that the experimenter changes or controls, and they are assumed to have a direct effect on the dependent variable. The independent variables, for example, we might change the type of information. They might be organized at random, and the effects might have the amount of information remembered by other people. In this particular, we're going to set a small example here as we have with the flowers. The independent variable is going to have direct effects upon results on the dependent variable. Okay?
Yeah.
Sorry, 1 second. So, and the dependent variable is a variable being tested and measured in an experiment and is dependent on the independent variable. Often, the dependent variable is going to be quantitative, but it can be qualitative as well. These two variables are going to be connected throughout the process and are going to be measured every time every time we can. And it's going to be also planned how long or how often they are going to be measured. We have one last variable right here, which is the control variables. Are the variables which must be in some cases enforced in order to be able to replicate the experiment. For example, the type of plant in this example of the plant, the type of plant or the pot or the soil, everything, which is going to allow us to replicate the experiment. If we take one of the experiments, for example, of the little Albert, we may say that the independent variable are the knocks on the table, which are going to make the little boy despair or be afraid of the noise or the animals that they are going to be associating with fear. And the dependent variable is going to be the fear itself, which we are going to measure by in which way the behavior, in which way we can see the behavior of the little boy. The control variables in this case are going to be the gender of the boy, the age, the size maybe, and in some cases even ethnicity, in order to replicate these experiments, right? So let's go. After we move on from the variables, wait. We have one more. Okay, the extraneous variable or the confounding, which may confound us as well. Extraneous variables are all variables which are not the independent variable. Remember that independent variables are the variables that the experimenter or the researcher modifies, changes. But the extraneous variables, the researcher has no control over them, but in some cases may affect the result of the experiment. It means that in this case scenario, we have controlled which plant is it, the soil, pot, the size of the pot, the quality of the pot, even the materials made of that make the pot. And the independent variable might be soda, water, fuel, anything you want to add to the growing plant. An independent variable, of course, is the size, or in cases of the research, the growth, or the growth span of this plant, of this particular plant. But the extraneous or confounding variables might be temperature of the environment if we are not controlling it yet, because we may have the environment control as well if it is in a we may be controlling the temperature of the room as well for the growth of the plant, but in some cases the light cannot be controlled or will not be controlled, so on and so on. All of those remain as extraneous variables in some of the experiments. And all of the extraneous, one second, please. Sorry. Difficult with children in some cases. Okay, let's go back. Confounding variables. As we see, may affect in some cases the results of the experiments, but are not modified by the researcher. Okay, let's go. Now we have the second point, which is hypothesis. The hypothesis is a precise testable statement of what the researchers predict will be the outcome of this study. It means that once we see the problem and we want to test it out, we are going to establish some hypotheses, some of our ideas. And if we want to conduct a specific research, a specific experiment, we have to test one idea at a time in some cases, okay, to be able to get significant results regarding one variable or the other. And if we see, as in the plant example again, if we see one plant growing larger than the other, we may say that the problem is the soil. And in one of our hypotheses, we say, okay, the soil might not be the problem. It might be what we add to it, the water, soda, even other liquids might be toxic or not. Those ideas we're going to test in order to get our specific hypothesis. And here we have null or alternative hypothesis. The null hypothesis establishes that our variables have no connections to one another, okay? And the results are due to chance and are not significant in terms of supporting the idea being investigated, okay? The null hypothesis means that if we think that the growth of the plant is because of what we add to the soil, the null hypothesis is going to say, no, that has nothing to do with it. The two variables are not in any way connected, which is going to make the researchers drop their studies because it's going to fail. We don't want the null hypothesis to be accepted in most of the cases of the research, right? Because we need our variables to be connected in somehow, okay? In some correlation. So therefore, the alternative hypothesis says the complete opposite. While the null hypothesis says that there is no relationship between the two variables, the alternative hypothesis says, okay, yeah, there are not due to chance, and they are significant in terms of supporting the theory being investigated. If we say that bullying comes because of uh, reckless parenthood, we have the two variables right there. Bullying, or raising a kid being a bully, and then reckless parenthood. If they are not connected at all, it means the null hypothesis has been tells us that these two variables have nothing to do with it. And our alternative hypothesis states that they are related somehow. We don't know if positive or negatively. Okay? These are the two main hypotheses, while we have two other more, but in terms of statistical analysis: the non-directional hypothesis and the directional hypothesis, which means a two-tailed, the non-directional, also called two-tailed non-directional hypothesis, which predicts that the independent variable will have an effect on the dependent variable, but the direction of the effect is not specified, which is positive or negative. We don't know. Okay? Or a one-tailed directional hypothesis predicts the nature of the effect of the independent variable on the dependent variable. Okay? Whether it be positive or negative, or we may state the direction we want the variables to be correlating. I just added these graphs so we know why are they called two-tailed or non-directional, or one-tailed or one-directional. Okay, because it in the distribution graph it shows us like a two-tailed graph, and this is just as a one significant graph. Just that. Okay, we're going to see correlations and distribution of data after, in the future. Sorry, not now. Okay. Now let's move on to sampling. What is sampling? Sampling is the process of selecting a specific group out of a larger scale group of individuals for studying purposes. Okay. The target population is the total group of individuals from which the sample might be drawn. Of course, if we want to see what, if we want to study nowadays, or our country today, with all these social phenomena here in quarantine, we can conduct a lot of surveys even, or maybe remote observation, like an experiment of observation of natural environment. And we, of course, we cannot watch everyone all the time, the 30 million of Peruvian people, but we can take a sample of it. It has to be significant though. The target population is a total group of individuals from which the sample might be drawn. So target population means for which city, country, society, community we want the results to be applied for. And the sample is a group of people we are taking from the target population. Okay, if we want to study, for example, addiction to mobile, to social media on Paradise of Children School, we are going to say that the target population is Paradise of Children students. And we are going to take the sample of this target population. We are not going to study each and every of the 400 students. We're going to take probably 40 or 50 students, okay, as a sample, or maybe more, 100 maybe, but not the entire population. And a sample is a group of people who take part in the investigation, which we are going to observe, conduct surveys, interrogate, or submit to our experimentation procedures. Now, there is another term, which is generalizability, which refers to the extent to which we can apply the findings of our research to the target population we are interested in. Okay, we have researched about social media addiction in our school. That's just as an example. And what is it good for? To what extent we can apply what we have found here? Or can it be mended? Can we replace this addiction with other practices, maybe sports or reading or habits. Okay, that is generalizability. So sampling is very important for us to reduce our efforts to apply our experiment to the whole target population and still have significant results. Okay, there are several ways of selecting or sampling, and we have that we may do a random sample, where our target population has an equal chance of being selected. Okay, it means we do not care about any of the other characteristics of the people. We just choose people at random, maybe on the streets, maybe focus on different locations. It doesn't matter. Okay, which in some cases is not very good because we may have unpartialized data or results. It's not very good, a random sampling. We have also the stratified sampling, where the proportions needed are identified for the sample to be representative. Okay, this is very important. The stratified sampling it takes a lot of effort, a lot of resources, and a lot of money, but it gives us a better study. It shows us a more accurate result on our research. Stratified sampling means, okay, if we have 50%, if we have 60% of the population in Tacna as female and 40% male, for our research, we're going to also try to replicate these same statistics, not only of gender, but maybe of age or other social characteristics that we may add, like social status, like economical status. It's up to us which way we want to stratify our sampling. Do we want children involved in this experiment, or don't we want them? Anything. Okay, as you can see, to select each of the parts, like almost in the same proportions as in reality, like in a scale, it takes a lot of time, a lot of effort, and a lot of money, but they are more accurate in terms of results or findings. Okay, we have also the opportunity sampling, which in some cases is convenient.
Sure, I have a question.
But it's not very. It's not very. The results are not very reliable, because anyone who is available, anyone who can, and everyone who is willing to do the experiment is going to take it. Okay, it may be for money, or it may be for fun. Who knows? So in some cases, the people who know they are going to be part of the experiment, they are going to prepare themselves. So it's going to maybe modify the results. It's going to change them. We have also the systematic sampling, when the target population from a list. Okay, we use the target population and then like a list, and then choose it in a logical order. It's not random sampling. For example, random sampling might be if we have 400 students in Paradise of Children school, we choose and we make them form in lines one Monday, and then we get randomly one out of each grade. That might be random. We get 2 from one grade, 3 from other grade, 1 from other grade. That's random sampling. But systematic sampling, it might be out of a list of people, we're going to logically extract some of them. Like, for example, we have the list of the 400 students, and we get number 1, number 11, number 21, number 31, that in that systematic order. Okay, it has this. It's another way to do a random sampling, but systematically. Okay, and why do we do sampling? Look, these graphs in this figure shows us the entire population or the target population. And this is the graph of distribution of our results. Sorry. Of our results, which are going to be distributed in this way precisely if we order them. In a sample, they may not be as exact as the same distribution as if we were to analyze the whole target population, but it gives us the same idea or the same curve or the same graph with a little distorts. But just that. So we do sampling testing to analyze larger groups of people and to not spend as much money or as much efforts as we would if we were to analyze each and every one of those, like they do in census. These are the results in census. These are for the experiments. Okay?
Teacher, I have a question.
Yeah.
About the stratified sampling. What do you mean by being representative?
Okay. Representative mean is connected to the size of the target population. For example, if we have 1,000 people or a group of 1,000 people of any school, and we are going to conduct a research in that school, we're not going to make the experiment with the 1,000 students, but how many students do you think we need to get results, significant results, for it to be applied to the entire school? 10? 20?
20, I
30?
think.
Huh?
20 or 30?
Look, there are a lot of rules in statistical approaches, and it's if we have less than 10,000 people to be as a target population, we have to do the 10%, which means if we have 1,000 students, we have to conduct the research with 100. Yes. Okay. For over 10,000, the proportions are less significant, which might be 5 or 7%. Okay. So it depends on the size of the target population. For a larger population group, proportionally speaking, is a smaller sampling, but in quantity is a larger sampling. Understood? I don't know if that yeah. So for the 30 million people that we have in Peru, the sample might be approximate to 100,000 people to be evaluated as a sample. Okay, and if we want to do a stratified one, we have to select, for example, in order to proportions. A ver, voy a explicar esto mejor en español para que se entienda bien. Se enfoca mucho en las proporciones, lo que es el stratified. Por ejemplo, si nosotros tenemos 1000 estudiantes en el colegio, el 70% son mujeres y el 30% son hombres. De los 1000 estudiantes, nosotros necesitamos 100 para hacer el sample, ¿ya? Entonces, como la proporción real es 70-30, la proporción del sample también va a ser 70-30, de inicial, el género. No solamente eso, si queremos hacerlo más estratificado, de la población total, que son 1000 alumnos, vamos a diferenciarlos por edades. ¿Cuántos de 5, cuántos de 6, cuántos de 7, cuántos de 8? Y hacemos otras proporciones, ¿entiendes? Por ejemplo, 7% de primero de primaria o 10% de... y así, ¿entiendes? Del total de los 1000 alumnos. Y de esa manera igual lo replicamos en el sample. ¿Ok?
O sea, ¿se podría decir que el stratified sampling es el más accurate?
Sí, pero es uno de los que más, es el que más gasto determina.
Okay.
Es el más costoso, ¿no? And it's not very easy to find willing all the people to be submitted to the research. That's why in most cases, in most of the research that we have studied, the opportunity sampling is applied. As you know, people were paid to be able to be in part of one research, like in Conley et al. Just as an example, or the Demen and Kleitman of rapid eye movement. So these are the sampling parts. ¿Por qué lo hacemos? Para replicar las estadísticas poblacionales de un grupo poblacional objetivo y reducirlo y que nos dé los gráficos similares. Ya está. ¿Ok? Now, let's go with qualitative and quantitative research. Okay, as we know, qualitative are characteristics, are descriptions, and quantitative are measurable and numbers. Very easy right there. But it becomes confusing when we want to change one into the other. Can we make qualitative characteristics quantitative? For statistical purposes, we can, okay? But in some cases, it should not be done. For example, qualitative researchers use a variety of methods to develop deep understanding of how people perceive their social realities and, in consequence, how they act within the social world. Okay, how do we get qualitative responses? With open questions. Easy. Okay, for example, what do you think about pizza? I don't know. A lot of people may have different answers and totally different. I like it. I hate it. I don't like it. I don't know what pizza is. So open questions are qualitative for research. And in some cases are good if we want to study specific cases, like in case study method of experimentation. But it becomes tedious when we want to apply qualitative research to these proportions of sample. It's almost impossible because it would require that a lot of scientists or researchers to be interviewing hundreds of or thousands of people, which cannot be done because for statistical purposes, it's too impractical and it doesn't show very, it doesn't give us the data we want for our research. In which way can we apply qualitative research though? Do you have any idea? Why do we need qualitative research? What do you think?
I don't know, because I don't think it's very like precisely with when we need to get proportions of percentage.
Mm-hmm. Yeah, but it's very, very, the line between qualitative and quantitative is very deep, it's very broad, it's muy ancha, okay? Because qualitative researchers focus on producing knowledge to be used by quantitative researchers. It means qualitative researchers dig out data to maybe write books, to explore different possibilities to be applied to larger groups of people. So one helps the other in some cases. And for example, we can analyze qualitative data like in happiness, in gender, eye color, description, anything that is a word is qualitative for us. Nos ayuda para iniciar un punto de partida en la investigación cuando queremos explorar nuevas cosas, ideas, nuevos parámetros, antes de pasarlo a un experimento cuantitativo. So qualitative research is very important as well. It might not be practical when we talk about large numbers of people, but it is useful for us to get new approaches, to get new perspectives, to be able to understand specific groups of people from the inside. Okay, like for example, we cannot consider psychopaths or sociopaths as part of a quantitative research or for society. It's not going to show us the same results. It's going to be like they lie, or it's going to be very imprecise for us. And in this,
but they are like part of the society in some way.
yes, but
So
it depends on the type of questions that we want. For example, I told you last year that every test, maybe 100 or 200 questions, have specific like cheat questions. Tienen preguntas trampa.
yeah.
Para analizar la validez del instrumento. ¿Ok? O sea, por ejemplo, puede ser tanto como que te gusta vivir en sociedad, ¿no? Te sientes contento contigo mismo, lo cual obviamente no todos pueden decir que sí, pero eso en muchos casos invalida la respuesta porque no es el foco de atención de la investigación. ¿Entiendes?
Mhm.
Personas con poca empatía social no pueden ser producto de investigaciones sociales específicas, ¿no? Obviamente van a ser producto, o sea, van a ser parte de investigaciones sociales hacia otro campo. No, eso no. We have quantitative research as well, which are measures, height, duration, length, okay? Quantitative research gathers data in a numerical form, which can be put into categories or in a rank order, or measured in units of measurement. Okay, rank order. This is where the Likert scale comes in handy. We may turn the qualitative data into quantitative data. For example, just for statistical purposes, gender. We know gender is qualitative because we have, well, biologically too, and let's say that by choice more, right? But can we measure if we assign one gender to one number, we may have qualitative responses. Or in the Likert scale says of happiness, for example, if we want to measure happiness quantitatively speaking, we may say 1, not happy at all, 2, yeah, barely happy, 3, like I don't care, 4, happy, most of the times happy, or 5, very excited or exuberantly happy. So in that way, we could change some of the qualitative attributes into quantitative one, just for statistical purposes. Okay, for example, in satisfaction, if we give out a speech, or if I give you one apple and I tell you, was it good or was it not? The response is quantitative or qualitative. Did you like it? Did you like it? If I tell you, ask if you like the banana or the apple, is it qualitative or quantitative?
Quantitative.
No, it's qualitative because it is an open question. You can tell me anything you want, right?
But your question was, did you like the banana? I can say I like it or I don't like it. It's like,
yeah, you could say I don't care. It seems the same to me. You could say anything you want.
Yeah.
It becomes quantitative when I say, okay, here is one questionnaire. Fill in the form, please, and you say you see the question. Did you like the banana? Yes or no? What color was the banana? I don't know. Green. What other color is banana?
yellow.
Green, red, yellow. I don't know. Yeah. So in that way, we can convert some qualitative into quantitative data. But as far as there is an open question, there is always qualitative. ¿Ok? Solamente para razones estadísticos vamos a convertir algunas cualidades o algunos datos cualitativos en cuantitativos. Nada más. Por ejemplo, en el sí y no, como tú dijiste, sí se puede convertir a cuantitativo porque el valor de 1 le podemos dar al sí, el valor de 2 le podemos dar al no, o 0 y 1, como tú quieras. O en la escala de Likert, como dice el nivel de satisfacción, vamos a calificar del 0 al 4 si te gustó o no. A ver, tú probaste la banana y te digo, del 0 al 4, ¿cómo te gustó la banana? Tú dices, la banana queda la manzana. 2, o tú dices 3. Ahí lo estás convirtiendo a cuantitativo. ¿Ok?
Okay.
Just for research. Okay. So in quantitative research, we have a lot to do, a lot to research, but it's mainly data. It's mainly numbers. And in qualitative research, as you see, anyone or everyone can give out its opinion. In quantitative, you do not want that because it's too much work, too much effort. You cannot graph ideas. It's nearly impossible. Okay, you cannot graph it. You can graph numbers, only numbers. So your job as a researcher is in some cases turn the qualitative research into quantitative research to build graphs. Okay. Okay. I don't know if you have any questions so far. Look, in CIANET, I put the link to the web page of Simple Psychology of Research Methods, where there is the research methods part 2, where are the other research methods, and then for you to be reading before we move on to the next stage. Do you have any questions?
No,
No.
I've already